we're going to do Chapter 9, Determine Suitability. So we're going to solve a common GIS problem, determine which areas are most suitable for a specific land use purpose. We're going to take advantage of the raster data model. And the first thing we're going to understand about a raster is that it is composed of a grid of cells instead of discrete x, y coordinates that define geographic entities. The cells contain values that are used to record and determine and define geographic phenomena on the surface of the Earth. So, for raster data, the cell contain values that are used to record and define geographic phenomenon on the surface of the Earth. Each raster cells represent a portion of the Earth, such as the square meters or square miles. I'm going to pull it out and show it to you. Raster data. All right. And usually has an attribute value such as elevation, soil type, or vegetation class associated with it. A surface which is made up of raster cells can be discrete data, which means that it shows distinct and a discernible region on a map, such as soil type, can be continuous data, which means that there are smooth transition between variations in the range of data. Elevation data is one of the most common uses of continuous raster. Typical raster datasets are extremely detailed and store a large amount of information, recording information about each cell and every cell. So when you're working with raster data, it's gonna be a little slower. So this raster continuous data represents elevation, and we can see the land change. So elevation and thematic map. So the raster continuous data represents elevation data. That this one. We can just read through, and then we have raster discrete data represent land cover, as well. And map algebra. So let's see if we have a raster map algebra. Let's just go back to map algebra. It's a language that combines that by this tool developed by Danny Darling. He is a professor from Yale University. Map algebra, a language that combines GIS layers, is a fundamental raster tool analysis. Raster cell values can be evaluated using functions and mathematical, logical, or Boolean operators. And output raster is the result of a cell-by-cell function performed on two input rasters. So a 3x3 grid added to another 3x3 grid produces a result grid in which the cell values represent the total of the inputs. Every raster cell has a value. Some cells may have a value of 0, for instance, representing no precipitation, and some cells may have a value of no data, which means that no values were recorded for that particular cell. No data cells are ignored in raster calculations. The ArcGIS spatial extension contains close to 200 geoprocessing tools to perform comprehensive raster-based spatial analysis. Wow, 200 for raster based. And these tools allows everybody to perform basic mathematical and logical operations as well as raster data set creation and processing. We're going to work both vector and raster data and using ArcGIS Pro standard tool as well as spatial analysis tool. So, right now I'm using a student trial software, so the spatial analysis extension is automatically licensed. If not, you have to buy a license. So, scenario, we're going to suppose we are a vineyard manager. The employer owns a large property in Monterey County, California. Much of it is already planted with grapes, but there are several unused blocks of land. We will use the enological knowledge and GIS skills to select the most suitable block for planting additional vines. To grow wine grapes in a moderate coastal climate such as Monterey County's, sunlight is the key ingredient. The more, the better for rich fruit and high yield. So the specific criteria is that the land must be mostly south-facing. For the longest sun exposure, the slope must be less than 14%. Because you want the vineyard to be machine harvestable, and finally, we want as little shade as possible. So, for example, even if a block is south facing, it can have high slope on either side, creating undesirable shade in the morning and afternoon. We're going to understand the topography in GIS. We're going to create and compare 3 layers: aspect, slope, and hillside. We will have to do some pre-processing before we dive into the analysis. Once we have analyzed the property, we will overlay a feature class showing existing vineyard so that we can access the available areas and decide which one is more suitable for planting. A special thanks for those people providing data that it's in the Skiving vineyards. They did all these in their vineyard. So to get the data in current site, they already downloaded the data from National Map Government. So the boundary coincide with the 2 large DM files. Let's look at the data real quick. Vineyard, it's right here. And let me just open it up and see what data they have. They have a vineyard geodatabase. We cannot just view from here. We're going to do from ArcGIS catalog. And so we will use the extent where reduce the minimums. The students' download size, they already have it, everything for us. The study area used a mask, a means of identifying areas to be included in a geoprocessing operation. So let's look at the data. Previously, we mentioned that 2 files. The first one is NND, Central Coast. The others, explained on page 362. Anyway, we're going to explore the data a little bit. Okay, that's the raster data. And if you want to read more about it, we can just view metadata. All right. Oh, that's a disaster. Anyway. Okay, so that's the description. Alright, we're going to prepare project data. The first one we're going to, let's close this out. We're going to convert the line property boundaries feature to a polygon feature so that it can be used as an exact mask. And we're going to use the extract by mask tool. It's just like clip, but here you cut the raster data. It's called extract by mask tool. Reduce the extents of the 2 elevation rasters so that they are clipped to the extent of the property boundary. And then we're going to expand one extracted raster to the other, resulting in a single raster that is coincide with the property boundary. Project the elevation raster so that it is the same coordinate system as the property boundary. We're going to right click on this and zoom to layer so that organize a little bit. We see a base map and a single line feature that demarcates the boundary of an approximately 1,100 acre property dedicated to viticulture. And we're going to turn on the NAD 1 and NAD 2 layer. This is 1. Gonna zoom out a little bit, and then this is 2. Turn this on and off. It's weird. I know. And then we're going to use the Extract by Mask tool to reduce the extent of the elevation layers to match the extent of the property boundary. And however, to use the property boundary layer as a mask, it must be a polygon because it is currently a line feature. Technically, 3 lines features. We can tell by looking at the attribute table. Let me just turn it on and off. So we must convert it to a polygon for this mask, and we will use the feature, the tool called feature to polygon tool. So we're going to search for the tool right now. Analysis and tools, feature to polygon. Okay, now we have feature to polygon, and we're just going to fill in those criteria. For the input feature, we're going to drag. We can just drag the here. There's a property polygon, and the property boundary line feature class. Notice that another input box appears. The tool provides the option to convert several feature classes at once. But now we're going to hover the output feature so that we going to type proper boundary polygon. So we hover the over the output feature class box to see the default output location. So the project geodatabase is right here, Vineyard geodatabase, and we're going to maintain the path but change the output feature name to property underscore boundary underscore poly. We're going to leave the optional parameters blank and run the tool. And then a new polygon layer, it will be added to the map. So right here, and we do not need this anymore, so that's a polygon. So we're going to remove the line feature and going to do remove. And we're going to, oh, I removed the wrong one. I'm going to remove this one. It's okay. We can just put it back, map, and add data. And where is our poly? Not community housing. It will be in our Vineyard. It's right here, and geodatabase, property boundary poly, and we're going to click OK. And then we're going to change the color. But right now we're going to clip raster layers. Now our property boundary is a polygon. We can remove forward with the clipping the elevation raster. So in the geoprocessing tool, we're going to search for open the extract by mask tool. If the geoprocessing pane still shown the feature to polygon tool, we're going to click back arrow to return to the search function. So now we have to go back and tool, and we will type extract by mask. Alright, spatial analysis tool, we're going to open it up. And for input feature, we're going to put an ID 1. And then for output,